Hi there. So I have decided to comment on a previous upload, which is in the same playlist. And the title of that upload is Pashto TTS Engineering Running Samples. And it's not a long video. It's just a 1 minute video, just highlighting the yeah the aspect or some of the aspects of working with of training TTS models for the Pashto language. What is TTS model? Is text-to-speech model. This is this thing when the computer generates text or something, then you click on this and then it will transform the text into speech. It will voice the text, so to speak. And so we know all. Actually, I can demonstrate this live on the chat, on the original chat. There it is. So, okay. So what happened? I was working on something, and so I came across a text, and so out of curiosity, because I have worked on Pashto text-to-speech models in the past, also just out of curiosity, nothing, it was not for professional purpose or something, because I'm interested. So as a data scientist, I take interest in training models, etc. So, and also as these things came up, the GPT-4 a year or so ago, so I also wondered how we would train a language or a voice model for Pashto. So I did some work on that. I have invested some hours of work and also made some transformations, etc., to train an English-trained TTS or to retrain an English-trained TTS, which is also called fine-tuning, to fine-tune it for the Pashto language. And and I saw that this is a very challenging job to do. There is one company back then, I discovered that company is an Indian company. They had already a good trained model for Pashto, but that was, of course, not open source. So, and extremely expensive. Yes, and now I have found out that also GPT offers this text-to-speech capability for Pashto. And so I tried to just take a random text and get it translated into Pashto and make the GPT voice that thing. Okay, so I chose this one, and then actually this here, the original translation by the GPT. But then when I played that sound, it sounded nothing like Pashto. It was a mix of Persian, Arabic, and Hindi. Okay, I cannot play it here because I don't have my recorder has no capability to make a in-device recording, so that will be not a good quality. But you can refer to this video, to the original. It's in the same channel, YouTube channel, and you can have there an impression of what I'm talking about, or at least of the vocalization function here. So yeah, and yeah, then I found out because I remembered my own work, and then I knew that we have to tweak this spelling of the text to make it easy for the language, for the TTS model to pronounce it. Okay, and so I did that here. This is a very simple example. It's just meant to build an intuition and just to give you an idea of how these things work. And I have um, come across a finding also in this short example. And I will share it with you towards the end of the video, but just we're not there yet. Okay, so what did I do? in order to make it easy for the TTS model to pronounce these things in a better Pashto, I tried to use these accents here and there, and then I played it again, and then it was still not nothing like Pashto, and then I tried to tweak it again and tweak it again, and then another trial and give it another try. So until I ended up arriving at, you see how many uh, trials I had at this thing, which is, if you play it, it sounds more Pashto than everything before that. But from the spelling, you would not recognize it as Pashto anymore, at least at the first sight, because you see Srali, Ke, and then you see here things like Shin, which is supposed to be Shin, Blue, or Au, which is supposed to be an Aleph and Wow only, but it was not pronounced like the Pashto Au. So I had to somehow help myself to an Ein and Wow. So these are things. I mean, we are dealing with machines and computers, right? So you have to find a way to trick them into doing what you actually want them to do. And here it's about how it sounds at the end of the day, and not how somebody has decided at some point how it should be spelled originally. So this is also important. And so I got there also this. There was also a conflict between our. Where is the other shin? With the shins. Okay, yeah, there is the shin. It's right there, and then there is shin and shna. So Shin Almas and Shna Daira, and it couldn't get a sense of that somehow, and so I tried to normalize them because Shna is actually the femalized form for Shin, right? Where it is again? The Shin and Shna. Oh yeah, I replaced this Abi. That's why. Okay, there is Shin and Shna. Okay, so yeah, but usually we never have a problem. Everybody who's somehow fluent in Pashto, he knows where to use which and why. And we never asked ourselves why this I is missing here, right? And so, but the computer, for the computer, it is not natural why things disappear as a pattern disappears. I mean, language models are, let's say, let's put it this way, AI models, these are built on pattern recognition. If there are no patterns in the data, this is the data, right? That goes into the model and produces some output. In this case, it is a voice. If there is no pattern, then you cannot build any model. You cannot make any inferences. So the pattern is important. And if the patterns are there, but they're covered somehow, right? Because there are exceptions in Pashto and things. So then you need to find a way how to uncover them and how to make them palatable to the computer and to the machine so it can see that there is a pattern. And where there is a pattern, a machine can learn from it, can draw conclusions. And so I made this pattern apparent later down there because I saw that this caused conflicts. So I tried transitional things and it didn't help until I arrived at a normalized grammar for Shin and Shina. Because usually if we build up systematic grammar for a language from the ground on, from square one. We start building up a grammar for a new language, right? Then we wouldn't come up with ideas to make things sound different just because, or to build in exceptional cases. Okay, and there was this exceptional case in the natural language between shin and shna, where the e or ya disappears, but then I normalized it back, and so I added this ya. Okay, so and then now we have shin and shina, and everybody would understand that also in Pashto, that this is the same word. They will recognize it. It's grammatically not wrong, actually. This is a normalized grammar. Okay, so I got things back to normal, if you will so. And then I tried to run this again and it pronounced it correctly. All of a sudden, it is not shna, the pronunciation, it is shina, but everybody will be okay with that. So it is not a challenge to anyone. It is intelligible, it is still Pashto, and it fits in well within the context. So the most important thing is to make a TTS language that is intelligible in the first place. Okay, and I saw from this that we may have this challenge of standardizing or normalizing Pashto grammar before we start to train a model that is expected to deliver reliable results. Okay, and so the thing that has never been done, this is the standardization and normalization, and also, yeah, sanitization of the Pashto grammar and also spelling. That might be necessary now to train these models, because otherwise you wouldn't get anywhere. So we need a group of people who work on these things and will prepare the texts in this fashion, and so we can train these models, because in the end of the day these things sound very theoretical now, but at some point in time, and this may be very far, but people will have to deal with a machine when they go and I don't know, to get an ID card or something. So there will be no actual natural agent or person that they can talk to. It will be a machine, and so it's important also for Pashto to have a well-trained model that is intelligible. Yeah. Okay. So, because for all those people who still wonder why there is no well-trained Pashto text-to-speech model, there at the level of, for instance, English or I don't know, German, Chinese, and then that's in part due to the dialects. Yeah, you have to deal with the dialect thing. You have to make one model for each dialect, and then but for all dialects, there is a common thing, a common step that has to be taken away first, which is the normalization and standardization of the grammar, so the models have not a hard time to pick up on patterns. And when I'm speaking of patterns, I'm speaking of voice waves. These things are actually voice waves, what come out from there, and what we have here as a letter that is vectorized and translated into a voice wave. Okay, and when we train a model, then we have to give him a lot of voice waves. So sample recordings, thousands and thousands of them, and it can then transform them into waves and signals and get the patterns.